Let me now explain the practical part of the course Paradigms of Computer Programming. In fact, it consists of two courses given in sequence, Louvain 1.1x, which is Fundamentals of Programming, and Louvain 1.2x, which is Abstraction and Concurrency. The prerequisites for Louvain 1.1x are basic programming skills. It doesn't have to be very much. You have to have programmed in at least one language and written at least a few small programs, at the very least, and also some elementary mathematics. This doesn't have to be very much either. Knowledge of sets, lists, and functions doesn't have to go much farther. And for Louvain 1.2x, the prerequisites are basically the contents of Louvain 1.1x. It doesn't have to be the full contents, but in some sense we do assume that you understand what was given in Louvain 1.1x. There are 6 lessons for each of the courses. We will give 1 lesson per week, and in Louvain 1.2 we have a 7th bonus lesson. So compared to the previous course, Louvain 1.01x, we have made some changes. First of all, of course, there's the split into 2 courses, each which has half of the material. Then there is now possibility of having a verified certificate for each course. There is in Louvain 1.1x some new material on computational complexity. There's also a new improved grader called Ingenious, which replaces the Pythia grader that we used in Louvain 1.01x. The Pythia grader had some problems, and we hope that the Ingenious grader will do much better. We also simplified the installation of Mozart using VirtualBox. So this lets you create images and basically lets you install on almost any operating system. So in terms of exercises, the exercises are very similar to the previous edition. There are conceptual exercises and programming exercises. The programming exercises use the Ingenious grader. The programming exercises are programmed in the Mozart programming system. So this you have to install locally, and as I mentioned, you can do this using VirtualBox. And there is, at the end of each course, a final exam. So in terms of the lesson plan, there are 4 main themes. So Louvain 1.1x covers the first 2 themes, which are functional programming and semantics, and Louvain 1.2x covers abstraction and concurrency, and we have here first abstraction and then concurrency. So in Louvain 1.1x, we talk first about recursion, invariant programming, basic techniques of how to loop and how to structure your program. Then we talk about data structures, lists, trees, and records, which are the most useful and powerful data structures. We'll also talk about computational complexity, and as a final crowning moment in this course, we're going to give the correctness and semantics, the formal semantics of a program, so you will know exactly how programs execute when you finish Louvain 1.1x. For Louvain 1.2x, we go further and we cover first abstraction. So abstraction is the idea that underlies object-oriented programming, which is an elaboration of it, and a practical language, Java, which implements it, including other ideas such as multiple inheritance and exceptions, which are a way of handling rare or erroneous conditions. And the final theme is deterministic data flow concurrency. So concurrent programming is very important, so we could not leave it out. And deterministic data flow concurrency is by far the simplest, but still an extremely powerful way of doing concurrent programming. And we will use it to do multi-agent programming with some very nice examples. For example, digital logic simulation. And in the final lesson, we will take a step back, look at all of the paradigms, look at how everything fits together so you can see the uniformity, how everything is structured, and also give some hints and links for people who want to further their studies. And then there's the bonus lesson on multi-agent data flow. This is the nicest general concurrent programming paradigm, so it was very hard for us to leave it out, so we added it in. The software that we'll use, so first of all is the 8x platform, which integrates Ingenious with the documentation, so the textbook and slides. And of course there are the discussion forums, and I will participate in these forums together with the teaching assistants. Then there's the Ingenious grader, which will give you feedback on your programming errors, and it runs with its own version of Mozart internally. And then there's the Mozart system. So basically Mozart implements the Oz language, which is the language that lets us express all of the different paradigms, you do need to install it locally. You can either use a simplified installation or, for the courageous ones, a complete full installation. So the course textbook is Concepts, Techniques, and Models of Computer Programming, published by MIT Press in 2004. It's still popular now, which is quite unusual for a programming textbook. In fact, it has garnered quite a reputation. So part of this book will be made available for free for people following the course.